Okay, guys, so to build off of exponents, we like to throw in a little lesson about scientific notation in here. Um, as far as scientific notation goes, we're going to talk about standard form and scientific notation form, and when it's appropriate. And we'll do some operations with scientific notation, which include multiplication and division. So, scientific notation, what's it look like? Well, normally you're going to have something out front that could be a decimal times base 10 to an exponent. All right. So this first part is called the coefficient. And it has to be between 1 and 10, but not 10. And it could be a decimal as long as it's between 1 and 10. Second part, the times 10, it's a base 10 is what we call it. And then obviously up here is going to be your exponent. We use scientific notation to represent really small numbers and really big numbers, right? So again, I just took this, I put a number to it, and I explained it. So the first thing we like to talk about is standard form. Well, standard form is what you're used to. So we're going to say write out the number. Because whenever you see numbers, normally you just have them written out, not scientific notation. So what you do is you take your coefficient, and then you look at the base 10 exponent. It's a positive 5. Because it's a positive 5, right? Positive means I'm going to go to the right. Negative means I'm going to go to the left. And what I mean by that is I'm going to take my decimal, and I'm going to move it 5 to the right. So I'm going to go 1, 2, 3, 4, 5. Well, you see there's some open spaces here. Anytime there's an open spot, you put a 0. So now the answer to this would be 342,000. So 3.42 times 10 to the 5th is 342,000. Again, that's a positive exponent, so I go to the right. So vice versa, a negative exponent, I'm going to go to the left. So I'm going to take my number that I have, my coefficient out front, and it says -4, so I move it 4 to the left. 1, 2, 3, 4. There's a decimal there now. So my answer is 0.1230 is what I saw, 7862. All right. I want you guys to try the next two. Think about where the decimal is on that first one. 5 times 10 to the 5th. Where's that decimal at within your coefficient? So again, pause it, try it. Times 10 to the 5th. Well, the decimal's right after the 5. So I'm going to move 5 to the right. 1, 2, 3, 4, 5. Add in my zeros. And then write out the standard form that we're used to. Hopefully you paused the video and you tried this last one as well. You should have got 0.0000. Should be 5 zeros and then 2, 3. All right, so that's taking it from scientific notation to standard form. Well, now vice versa, okay? I want to write a big number into scientific notation. So what we do is as I work left to right, I find the first number. So if I'm going this way, 3 is my first number, and then I put my decimal right after that first number. So my coefficient is going to be 3.789. And then I immediately write times 10 to that, and I got to figure out my base. All right, so I'm going to take my decimal, I'll move it to the right. Right, we talk about right being positive, so it's going to be a positive exponent. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's times 10 to the 9th. Okay. Same way here, as I work left to right, I get to 4, that's my first number. Put my decimal after that, so my coefficient's 4.35. So I gotta look at where I put it, and then I gotta count how did I get from there all the way back to the original one that they gave me to start the problem with. So I'm going left with this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's times 10 to the negative 9. Right? And think about this, really big numbers are going to have positive exponents. Really small numbers, really small decimals are going to have negative exponents. Okay? So go ahead and try the next two by yourself again. Pause the video. Hopefully for this one, you wrote 6.78 times 10 to the 15. And the bottom one, put my decimal here, 1, 2, 3, 4. Hopefully you said 4.32 times 10 to the negative 4th. Okay? So that's taking it from standard form to scientific notation. So now we're going to kind of build off this, and we're going to talk about multiplication within scientific notation. So if I give you two scientific notation numbers and I say multiply, here's what you do. You take the coefficient of both of them and you multiply them. So 3 times 2 is going to give me 6. And then I take my exponent rules. This is 10 to the second, that's 10 to the fourth, right? They have the same base, so what do I do with the exponents whenever I multiply? Well, I add them. All right, so this is going to be times 10 to the 6, and that would be your answer. If I said write it in standard form, could you write it in standard form? Yes, I would just take it, move my decimal 6 to the right, 1, 2, 3, 4, 5, 6. And that would be my answer. So this is standard form. This is scientific notation. But you need to do scientific notation first before you go to standard form. So again, I take the coefficients, I multiply them, and I take my exponents and I add them. So go ahead and try the second one down here. So hopefully you're saying 12 times 10 to the 8th. But here's the thing. If I say times 10 to the 8th, right? I mean 12 is my coefficient. 12 is not between 1 and 10. So I got to take this and I've got to adjust it. So right now my decimal's to the right of 12. I'm going to move it to the left one. So I'm going to say 1.2 times 10 to the, and when you move it to the left, you add 1 to your exponent. So say times 10 to the 9th. So 1.2 times 10 to the 9th would be the final answer that we're actually after. If you did 12 times 10 to the 8th, awesome, you did the first step correct, right? We're going to add the exponents, multiply the coefficients, and then from there you have to make sure it's in scientific notation form. All right, now vice versa, division within scientific notation, right? We're just using exponent rules. Kind of the same thing. I'm going to take my coefficients. I'm going to divide those. So 18 divided by 4 gives me 4.5. And then don't forget, in division, what do we do with the exponents? We subtract them. So that's times 10 to the second, because that takes 6 minus 4. Okay? Go ahead and try the second one again. Hopefully whenever you divide it, you got 0.417. We'll kind of cut it off because it repeats. And then you subtracted your exponents, so you got times 10 to the second. But here's the thing. I got to move this decimal 1 to the right to make it between 1 and 10, right? So I'm going to say 4.17 times 10 to, now move it to the right, I subtract 1. So I'm going to say times 10 to the first. All right. So that is scientific notation. If you guys have any questions over it, make sure you ask. We throw it in here because it has kind of follows exponent rules, right? Especially whenever we multiply and divide. So again, reach out if you're struggling with this. There's going to be a homework assignment. Make sure you get that done by the deadline. Otherwise, have a great day, guys.